For this FRQ, it says the function f is twice differentiable for x greater than 0. F of 1 is 15, f double prime of 1 is 20. Values of f prime, the derivative of f, are given for selected values of x in this table above. Part A, write an equation for the line tangent to the graph of f at 1. Use this line to then approximate f of 1.4. To write the equation of a tangent line, we just need point and slope at x equals 1, and we're given this value right here, f of 1 is 15, and then we also have f prime of 1 is 8, so we're going to plug those straight into point slope form. And here's the equation of your tangent line. So 1.4 is approximately equal to 18.2. Part B says use a midpoint Riemann sum with two subintervals of equal length and values from the table to approximate the integral from 1 to 1.4 of f prime of x dx. So if we use two intervals of equal length, we're going to go from 1 to 1.2 and then 1.2 to 1.4. And we'll use these values right here. 0.2 is your interval length, and then you have f prime of 1.1 plus f prime of 1.3. You end up getting 4.6. It then says use the approximation for the value we just got to estimate the value of f of 1.4. Show all computations that lead to your answer. So in order to find the value of f at 1.4, we're going to use the initial condition that f of 1 is 15. So to find f of 1.4, you're going to start with f of 1 plus the integral from 1 to 1.4 of f prime of x dx. F of 1 is given, you get 15, plus this value that we just got right here is 4.6. So you end up getting 19.6. Part C says use Euler's method starting at x equals 1 with two steps of equal size, and we're trying to approximate f of 1.4. So I'm going to use this table. You have x, y, you have dy dx times change in x is approximately equal to change in y, and then you take the values from this column and add them over here on the right. You're starting with the initial condition f of 1 is 15. We need to do two steps of equal size to get to 1.4. So that means we're going 1 to 1.2 and then 1.2 to 1.4. Each time we're adding 0.2, so that's going to be our change in x. Okay, the first thing we need right here is dy dx, which is the slope when x is 1. The slope when x is 1 is 8. So slope is 8, change in x is 0.2, you get 1.6. Then we're going to add 15 and 1.6 over here. So 15 plus 1.6 gives us 16.6, and then we drop that value down to the next row. We need the derivative when x is 1.2, and we're going to get that straight from the table. F prime at 1.2 is going to be 12. So you get that f of 1.4 is approximately equal to 19. Part D says write the second degree Taylor polynomial for f about x equals 1. Use the Taylor polynomial to approximate f of 1.4. So our formula for our second degree Taylor polynomial is going to be f of 1 plus f prime of 1 over 1 factorial times x minus 1 to the first power plus f double prime of 1 over 2 factorial times x minus 1 to the second power. And we just need to plug in f of 1, f prime of 1, and f double prime of 1. And all of these values are given. F of 1 is 15, f prime of 1 is 8, and f double prime of 1 is 20. And now we just want to simplify our factorials. So you end up getting 15 plus 8 times the quantity x minus 1 plus 10 times the quantity x minus 1 squared. And now we're going to use this to approximate f of 1.4. So plug in 1.4 for x, and then using your calculator, you end up getting 19.8.
No, there's nothing that